to skip some space because remember, we did not do all of 4.1 in class.
Oh, you're right.
We did not do all of 4.1 in class. So if you didn't watch the video or didn't access, I think the PDF is attached to homework 23 or something, right? With the full notes. You are going to want to get the rest of section 4.1 notes. As Caitlin reminded me, that homework is not due until tonight, technically. Remember, I'm giving retreat people a little bit of extra grace. But I also have the homework open right over here. I'm going to go quick back and forth. Bloop, bloop. Oh, that's not the right one. Bloop. So that those of you that did start homework, if you got stuck, we can talk about where you got stuck and help you kind of get all the way before you submit tonight. And I think the deadline's like 11:59 or something. And the reason why I wasn't too upset making the deadline for 4.1 not until tonight is because 4.2 isn't due until Wednesday. Oops, it's not up there, sorry. Wednesday.
Oh, she dropped out. Yeah, she dropped out. What a boomer.
You guys not turn in your chapter 2 correction?
No,
What more did you
you
do?
said
I had them do it tomorrow on the board. Okay.
I thought they would do next Tuesday.
That's what they said last week.
Then it's just on Tuesday.
You still have it. Alex, why just corrected it? That's
No, it's actually okay.
Good.
For me, it is. Well,
No tablet today?
Yeah.
I'm passing.
I'm just stressed right now. Like, yeah.
I have 10%.
More than this week or more? Not fucking no.
You sent me to write down the number of detox. You got 1%. Alright, you guys are taking 4.2 notes. Not due until Wednesday. It's unit circle, so in some ways it might be an easy homework. But in some ways, some of you are like, okay, if I draw the circle, fine, I've got it. But like with a lot of things this year, I'm going to try to increase your understanding of it to make it easier when you actually do it. Remember chapter 3 with exponentials and logs? They're just puzzles. You just got to learn the rules. The properties, the condensing, the expanding, the inverse, the one-to-one. Use little tricks on your calculator like second log or second ln to remember what undoes those weird ones. You got to peek at like future math and science and how ln's show up, but we don't need to memorize that stuff. Chapter 3 was all about, can we get you to not be afraid of exponential logarithmic, but to know how to legally deal with them if they come. Chapter 4, it's introducing trig. So 4.1, you were here last Thursday. I introduced the idea of a radian. And a radian says, if you could find the radius of a circle and make your own ruler with that being the unit, instead of 1 centimeter, 2 centimeters, 3 centimeters, making it 1 radius, 2 radii, 3 radii, and you were to wrap it around whatever circular object you had, you would get the exact same thing every single time. Well, you would have some measure of error because of your instruments. So you probably wouldn't notice that it was the exact same every single time, but you would see a pattern. That you get about halfway around your circular object and be at a little bit of more than 3 radiuses, or radii. To be specific, 3.1415926 if your instruments were super accurate and super precise. And to get all the way around the circle, it would take 6.28-ish of those radii. That way of measuring angles is called radians. Degrees are the man-made construct of a little one. It takes 90 to get all the way to a right angle. It takes 180 to get to a half circle. It takes 360 to get all the way around. but it's not based on measurement at all. It's only based on rotation. So section 4.1, we covered notes on Thursday, but wait, you guys left on Friday, so how on earth did we finish 4.1? We didn't. The video was posted online for you guys to watch and finish the notes. Or at least the PDF was posted for you to finish writing the notes before tackling the homework that I made due tonight at 11:59 p.m. So that if you didn't get to it this weekend, you would have this afternoon, this evening to finish it up. Does that make sense?
Yeah.
Okay. So, even though we're coming back here to the unit circle in just a second, some of you at least got it started. Some of you didn't go on retreat. Some of you that did still peeked at pre-cal last night. So I'm curious, for your benefit and for the benefit of your class that might not have done it yet, is there any place in homework 4.1 where you got stuck? Can I answer those questions now? I'd love to. And people who haven't done homework, you can throw it in the back of your homework spiral and be ready for those questions when they come. Yeah, Megan? 47? Yeah. Okay. So if you guys haven't done homework, that's okay. Go to your workspace. Because in 47, something weird shows up. You guys want to grab out your calculators. I'm going to show you how to use them to help you on stuff like number 47. Good question, Megan. So number 47, there all of a sudden means, what? There's a tick mark? What's the tick mark mean? Or it's like a quotation mark? So, as you guys look at your homework, or as you at least look at this problem that's coming in your homework, number 47, the directions say convert to decimal degree form. So right away, you know for 47 that this is 54 and a little bit. But how much? Well, if you were to go in your notes, you would have seen that whenever you're looking at some sort of angle with any of these markings, this guy is called a degree. This guy is called a minute. Yes, like times, but not. And this guy is called a second. If you watch the video, do I talk about degrees, minutes, seconds in the video? I might not have. It might have been like an extra add. I think it's in the PDF. Let's go peek at it real quick. You guys have your notes, right? Can you just turn back? Did you get these pages taken in your notes though? No? Okay, so then go back, turn back to the very end of 4.1 that you took from the video. This would have been something I would have added on the next day, which is technically today, so that's perfect. Because Friday is what the video would have been. Let's talk about this DMS thing. So, 1 degree, 60 minutes, 306 or 3,600 seconds. Mrs. Leon, don't you guys talk about dimensional analysis and building bridges with units?
We talked about that in WAP too.
So check it. These are just conversions. Okay, focus, focus. Focus, focus. So, degrees, whole degrees have a little degree mark. Minutes, there's some sort of, wait, there's 60 of those and one of those? 60 minutes in, yeah, you can think of a degree like an hour. Not that, this isn't time, it really is like a portion of a degree. Now, wait a minute, some of your brains are like, a degree is so small, right? 90 of them? 1 degree would be where? Right? Like that's a degree? Why would you ever want to split up a degree to be smaller? I don't know, on a cellular level, do we need to measure angles? Huh?
A really small thing like a microchip.
Okay, maybe something really small or maybe something really big.
Like navigation, like if you like
Exactly.
Like it's like that, it's like that. Like eventually literally like that.
Exactly. Do you guys have any idea what Alec is talking about? If I draw 1 degree, how long is it really small for?
Like just that much.
Well, but as soon you guys see what's happening, right? Like you can barely see it here, but what's happening as my arm goes out? Now, I know it's not perfect. What's going to happen as my arm goes out and 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 out, right? Isn't it going to start to widen? Mm-hmm. Why? Because the bigger, well, hold on. Latitudes and longitudes, don't those measure like global positioning? Right?
Yeah.
And aren't they measured with degrees? Yeah. So if you were to take the entire circumference of the Earth and cut it into 360 equal portions, because it is circular in some way, shape, or form, right? How far apart would those think? The entire, we could say the equator, right? If we were to split split that up into 360 portions, how wide would be the distance between them? Very big. Yes, very big. And so 1 degree has or covers a huge amount of distance. And so we need to say, we have to split that up into minutes. But guess what? We can split that up into seconds. So if you're thinking about latitudes and longitudes being measured in degrees, well, maybe that makes a little more sense as to why we have to make it smaller. So kind of like an hour into minutes and into seconds, a degree can get split into something smaller, something smaller. But guys, do you see how it's built on 60s?
Yeah.
1 minute is 60 seconds. 1 second, well, he's a very tiny piece of a minute and a tinier piece of a degree. But the long story short, 60 minutes in a degree, 60 seconds in a minute, we can kind of use our understanding of time to help us. So check it. If this one is an example for, and I can kind of see that, kind of not. There you go. Okay, let's say you're given this. 13 degrees, 2 minutes, 10 seconds. That's how you would like name it. And they're trying to say, okay, but wait, what's the decimal equivalent? Now, over here I have the answer because I've already solved it. Because I attached the notes from last year. No, it's 1 repeating. So 13.036111.
Oh,
Does that make sense? 1 repeating. Sometimes it'd be way more helpful to have the decimals, but sometimes, especially with instruments, it'd be way more helpful to actually know like the smaller amount. Think of it this way. If you were to ask me how tall I was, I know this is dumb, I just keep coming back to it, but it worked with IBT. And I was to say 6.2. How quickly does your mind go to what that is?
It doesn't.
It doesn't. So when I say that I'm 6'2", your brain isn't thinking decimals. What is it thinking?
Inches.
Feet.
Feet, and then a smaller measurement of inches, right?
Yeah.
Because you're more used to thinking about inches than you are thinking about decimal feet. So wait, what would the decimal be for my 6 feet 2 inches approximately of however tall I am?
6.2.
No, what? Why? Because there aren't 10 inches in a foot. There are 12. So wouldn't it be 6 and 2/12? Ew. 6 and 1/6? Ew. 6.1666666. Do I really want to tell you that I'm 6.1666666 of a foot?
No.
No. So I use 6 feet 2 inches because it's a lot easier for us to handle. Does that make sense?
Are you 6'2" or 6'?
I'm 6'2". So I'm 6.166.
Oh.
I guess I could round to 6. Anyway, coming back. Sometimes decimals are helpful. For instance, if you were doing something like, no one really does this anymore, do they? Do any of your moms, like when they go to the grocery store, actually put stuff into those scales to see how much they are? So it's like how many pounds?
Oh, I do that.
That's how, why is it easier for pricing to use decimals?
My brother just pushes his hand
Because
and
you
stuff
can
like
make that
those.
into.
Or even like at the meat counter, like the deli counter, right? Don't they like always put and then slap a sticker on it? And that's how. Why wouldn't they want to go to all of this? Because they'd have to have like a price range for that and for that and for that instead of just doing one price per pound and just measuring in pounds. So sometimes you want to stick to one unit and sometimes you want to separate. I don't know if that resonated with anyone. But anyway, long story short. If they tell me for instruments, it's great. 13 degrees, 2 minutes, 10 seconds. How did I get to this? Well, what did you see me do? What did you see me do to those 2 minutes?
You converted it.
I built a bridge. Do you see them?
Yeah, I see them.
Look,
Solid meal.
2 minutes to 1 degree to 60 minutes. And then what happens to the minutes when we multiply?
They cancel.
Look.
At least we don't.
So 2 minutes is 1/30th of a degree.
I don't
But
get
then
it.
what do I have to do with the seconds?
You have to. convert that.
The same thing. I have to get it all back into degrees, away from like their smaller measurements. Which is what you guys just did with my 2 inches. You said, 2 inches to 12 inches is how many feet? You did a little bridge in your head without even realizing it. Dimensional analysis. So I took my 10 seconds and I multiplied him. I went straight to degrees. But could I have gone to minutes first and then to degrees? Either way.
You have to.
So 1/3600 and then I seconds and then I have my degree. Now, so to get rid of things we don't want. So then check it. I have my 13 degrees plus my 1/30th of a degree plus my 1/360th of a degree. And then, okay, I was being snazzy and I just went to fractions and I'm like, yay, look, I can get it all. But then you would have had to do long division to make it match. at some point go to your calculator. It's not a big deal. You're just trying to figure out what is this in terms of decimals. However, here's something snazzy. Have you guys ever noticed that on your calculator you have an angle menu?
Yeah.
Ooh, there's something on your calculator that knows how to do this? Angle menu. It's second apps. See it? See it? Look. Second
Yeah.
apps.
Oh.
Ah! There's a degree, there's a minute, there's a weird little R, maybe that's seconds, and then there's a DMS. So what if I was to plug in my 13 degrees, oops, I didn't want that, sorry, my 13 second apps degrees, and my, what was it, 2?
Yeah.
2 second apps minutes, and my, okay, let's see, was it 30?
10.
Oh, bummer. Okay, let's see if that R is what I want it to be. Ta-da!
Bruh.
The R is not what I want it to be. Well, that's okay. In our notes, it wasn't an R for seconds. What was it?
2 would be a little better.
2 is okay. You could try that. It's not going to work either.
Oh.
Why? Ready? Do you guys see that there's a quote?
Oh.
Has anyone ever used it when they were typing messages to their friends instead of doing their calculator math?
Yes.
Probably not because it's a quote. But either way, alpha
Hey,
plus. There was a quote somewhere else, so the programmers said, like, hey, it doesn't mean anything unless they put it with degrees, and then all of a sudden it means something. Okay, 13.03610, which is the same thing as 13 plus 2 over 60 plus 10 over 3600.
Yeet.
Wait a minute, what if, oh, you know math people, if they're asking you to go from this notation to that notation, a single degree, what else do you think they're going to ask you to do?
Back again.
Oh, is there a way to do that?
Yeah.
Didn't you guys see that DMS button a second ago?
Yeah.
What does that do? That says, I'll take a decimal and I'll make it degrees, minutes, seconds.
Oh, that's what it means?
Oh, look at
That is
that!
so cool.
So anyway, that second apps menu kind of cool.
Yeah.
That's
But is it technically building bridges?
Yeah.
Yeah.
But if you put a camera on the calculator, so you take a picture of the camera.
What if somebody's talking over it?
So.
That won't be dangerous at all. The day that kids literally learn nothing anymore. Anyway,
I would love that.
how would you go back the other way? Guys, going to DMS is kind of nasty because you have to go from a decimal and then multiply that by, see, I flipped it to get rid of the degrees and to get to minutes, but then you only keep the whole minutes because then you take the fractional minutes and say, okay, how many seconds? And you go backwards. And then at some point, there's nothing smaller than a second, at least for us to deal with. You guys could research. I'm not sure if there's anything smaller than a second as far as for navigation. So we just leave that decimal there. So we want to be precise, but we have nothing else to break it into. It's kind of going from, what, miles to feet to inches and being like, forget it. Of course, with the metric system, you can just keep going and going and going. But anyway. Okay, so Megan, all I have to say, thank you for asking because you're right, the notes didn't touch on it at all. So when you guys get to number 47 in homework, oh, it doesn't even look that bad, maybe. Number 47 says, what did they give you? They're kind of the same thing, I think, just degrees and minutes. So, wait a minute. If I want to convert this, isn't the 54 already in degrees? What am I really trying to convert, guys? Yeah, so let's take the 45 minutes. Do you guys remember the conversion?
1 over 60.
Like you said.
1 degree over 60 minutes. 45 over 60, that's a thing, right? Because 45 is 3/15 and 60 is 4/15, so 3/4. Hey, isn't that just point? No. That one wasn't bad. But technically you're built, oh, sorry, I didn't put my minutes mark.
The bridge.
There you go. Don't build a bridge, get rid of what you don't know. Okay, any other places that we got stuck in homework besides DMS, degrees, minutes, seconds? Helpful for navigation. Okay. The examples are in the notes if you guys want to write it down. To that end then, tomorrow we're going to be grading this homework and making sure you guys are good on it. Sound good? Because tonight you're turning it in. Let's go ahead and then get to something that even if it's not your favorite, yes, we're gonna probably go over that one. Well, it's your homework, so let me have you guys start it first. But when you see RPM, if you drive a car, maybe you know RPMs, because the RPMs are when you're shifting gears, or I guess automatics.
I can
It starts running. It means revolutions per minute. To be honest, the key is building bridges for this whole one, to get rid of revolutions or to get rid of minutes, etc. But we'll see if you figure it out. If not, we'll talk about it tomorrow. Unit circles. Okay. Remember how some of you, and maybe you don't remember, but I'm really hoping you do because it was a really cool reaction. I think it's actually one of the best reactions I've gotten. Do you remember what was cool about this page that you guys all responded to?
The most common radian measures.
You just add pi, 1 over pi. Pi over 1.
You just add because it's all about fractions, right?
Or you just add pi over.
Take one back round. Did anybody have issues drawing a circle in a nose just a second ago for section 4.2? Guess what this is? A circle tracer. It's super high tech. I bought them from a random grocery store or something. So, trace the circle in the. How are you going to center the circle on what this is called as a patty paper? Because it goes in between like deli meats, deli cheeses, in between like ground beef patties for hamburgers. Anyway, patty paper. How are you going to center your circle on the patty paper? Because if you don't center it well, it might not work out well. Anybody have an idea about how to find the center of this square? Priyanka.
Fold it like into 4.
Hot dog, hamburger.
I never got one.
Horizontal, vertical.
No,
Oh, there's one cut per group-ish. You guys are going to pass it around. You need to fold your patty paper. I got you. Horizontal and vertical. Like you're making like what? A greeting card in elementary school, right? Did your teachers ever use hamburger hot dogs?
More good.
I think Mr. Toy said building.
So fold it. Jane, don't worry.
Mr. Tooley said hot dog.
Fold it. Horizontal. Fold it vertical. Into fourths. Hey, how many quadrants are there? 4. Ooh. So when you open this up, are you going to see all 4? I see all 4, don't you?
No.
You guys trace your x-axis and your y-axis? Because that's a thing in the unit circle, right? We have x's and y's in circles.
Patty paper.
How come I can't fold?
Is there a boomer?
Now, as you guys are getting your fold, do we now have a center of the circle? More or less. You can make like that point in the middle, it's the origin or it's the center of our circle. Now here's where it gets a little bit tricky, except your cup is see-through. Can you try to center, as best you can, your circle over that middle point? And then I would do it with a pen. If you want to do pencil, that's okay too. Actually, you might make mistakes. Use pencil. Trace that circle all the way around. Trace that circle all the way around. It's going to be a little bit approximate. We'll see, we'll see. Actually, if you guys want to be super actually, you know what you could do? If you want to be super snazzy? Oh, I don't think it's perfectly proportional though. No, it's not. Never mind. My idea failed. Center your circle around. Circle! Equation of a circle. That's something that we've done before. X squared plus y squared is r squared, right? Except a unit circle. A unit circle says great. Radius, yeah, that's a thing. But we're going to call that radius, remember? Units of radii. We're just going to call it 1. Circle could be big. Circle could be small. We're just going to call it a radius of 1. Because we could say 1 radius, 1 unit. We could always use 1. So we're tracing our x. We're tracing our y.
So I can gauge it.
You have that point in the center, and you're kind of having to stare through your see-through cup and trying to get it as centered as possible, and then tracing your circle.
I think you circles kind of stuff.
Thank you.
Almost have to use a dot. I can have another circle. It's one of the easier.
You can kind of look at the left and the right and the top and the bottom and kind of try to position it evenly-ish.
Mine's quite big.
Good for you.
Live check. Live
If
check.
you want to test how well you did, you ready? This is going to be the fun part. If you want to test how well you did, you might want to fold and see, because you should be able to see the circle. Does it match up on the other side?
Exactly. Oh, never mind.
You might want to refold it. Oh, it does match up on the other side.
It does. Oh, it's not good though.
And you can fold the other way and see if the circle matches up. Should be pretty close. I kind of have to like fudge, whatever. My folds a little bit.
So cool. Everybody's so cool. I can't believe this.
But, ready? How many degrees is this if I fold it into my quadrants?
90.
90, right? Now, half of that would be 45. True. Okay. This is 90. But what is that in radians? It's like one of these radii, but a little bit more. That's awkward. Remember, there's one thing we want to keep in mind with radians. There's one thing we want to keep in mind in radians, and that is that 1 pi is equal to 360. No, it's not. Wait, no.
That's 2 pi.
If you guys watch Byhart, Recreational Mathematician, has a great YouTube channel. She would say that we should have never even made pi a thing. It was silly because it's only half a circle. We should have had this other Greek letter called a tau, who stands for 2 pi. We should have said 1 tau, 1 circle. It's way easier. Sadly, 1 pi is only half a circle. Now, this is something silly. Verging on, oh yeah, the clocks are on. Oh, that's throwing me off. We have another 12 minutes. Okay. You guys, have you ever heard of a pizza pie?
Yes.
Pie Day. We're going to totally take advantage of the whole pizza pie thing to make it way more fun when we celebrate. But coming back. Okay. But aren't most pizza pies circular? Let's not even go into the really cool, like, square ones.
Oh.
Deep dish.
Deep
But
dish.
not going into squares. Wait, pause. There's a dilemma because a pizza pie is a full circle, 360 degrees. That doesn't help me remember
It's a
him.
2 pi.
Nah, even better. What's the same idea of a pizza, but even better, and only a half circle?
A calzone.
Calzone! Woo! There we go. So we're going to be thinking of calzones.
My first meal at BC was a calzone.
Last year we totally had people who had never had a calzone before.
What?
I think for Pie Day we should definitely, in true celebration of pie, have calzones instead of pizzas, but either way. Okay, calzones. A pizza folded. Double the gooiness on the inside. Okay, so calzone. If we're thinking of fractions, I mean, you guys the other day said it's just fractions, and that's exactly what I'm trying to teach you. It's just fractions. We're going to think of a pie as a calzone, it's a half circle. Okay, 180 degrees, half circle. Now, within all of these, what we're going to talk about with all of our different radians, remember there are points. There are points where these special angles hit the circle. And these points have adjacent sides and opposite sides. Ooh, that's right. This is the adjacent side to the reference angle. This is the opposite side to the reference angle. And this is the hypotenuse, but oh wait, that's right, calling all the radii just one, like one radius is 1 unit. It can be a big circle, a little circle, the radius is 1 unit, they're all one. Just the one changes from centimeters to meters to something huge, kilometers. All of the coordinate points for any angles relate to trigonometric ratios. And that's why the unit circle is important. Because technically, x is x over 1, and x over 1 is adjacent over hypotenuse, and adjacent over hypotenuse is a cosine. Y over 1. Y over 1 is opposite over hypotenuse, and opposite over hypotenuse is sine. Oh, I think we're trying to get to SOHCAHTOA.
So,
And SOHCAHTOA.
Joseph Howe. Thank you, please.
So each of these special angles hits the unit circle as, wait, what special angles? I don't have any. All I have is a circle that's like cut into fourths. Oh, that's right. Wait a minute, though. Didn't we just talk about how if we start are in standard position and don't rotate at all, isn't that going to be 0? 0 degrees, but also 0 radians? I need you guys to choose where your 0 is going to be, your positive x-axis. Get your circle somehow situated and choose your 0. Once you choose your 0, you can make an ordered pair for that 0, right? 0 radians, aka 0 degrees. If we're just measuring that the radius is 1, wouldn't this point just be 1, 0? You guys agree?
No.
Well, but the radius is 1, so I go out the radius. X is 1, Y didn't go anywhere, so 1 zeros with the angle 0. And we talked about half a circle. Half a circle, how many radii? How many radians? Go over there. Pi. So we can put pi as our angle measure here, right? And what point are we at now if we're on the opposite side of the origin? Negative 1, 0. Hey, what's halfway in between 0 and pi? Half pi, half a calzone. Oh, hey, that's where the pi over 2 comes from, right?
Yeah.
And the pi over 2 is going to have, oh wait, you just go up the 1 instead of going over the 1. Isn't that the 0.01? So, if you only have the first quarter of the circle, you have half a pi, half a calzone. Then you have the whole pi, 1 whole calzone. Then you have 1 1/2 pi, so 1/2, 2 halves, 3 halves. Remember, count by fractions is what we saw last week. No. Doesn't apply right now. 0, 1/2 pi, 1 whole calzone, 1 1/2 calzones, and then if we're back here, don't we have 2 whole calzones now, guys?
Yeah.
So it's kind of weird in that pi does relate to circular objects, but sadly pi just relates to half a circle. But so far we have, well, technically like 1/3 of our unit circle done. Kind of 1/4, but kind of 1/3. Okay, what's the easiest one to find next? We had our 90s, right? Get back to the fold.
Pop the 90s. 90s.
What happens if we take the 90? Ready? It's a folding game. And we fold the 90 in half.
45.
45s. What happens if we take the 90, get back to like a first quadrant, and we fold it in half? Now we have 45s. Hey, but if you unfold that, aren't you going to have 45s like all over the place?
Like a snowflake.
Yes, then trace that to the 45 angle line. Because you've just cut both your calzones. Remember, 2 pies? Have you just cut both of them into fourths? That calzone's in fourths. The other calzone's in fourths. I have 2 pi. I have 8 fourths. So my calzone just got cut into fourths. So therefore, does it make sense as to why this guy is labeled pi over 4? Now some of you have another way of remembering this guy. Has to do with conversions between radians and degrees. If you remember that pi and 180, remember 1 pi is equal to 180 degrees, 180 degrees is equal to 1 pi. You could technically take that pi over 4 and be like, hey, I can always do this conversion. Although, hold on, wait a minute. This is radians. If I want to convert, I actually need the degrees to be on top because we need those units, the radians and the radians to cancel out. So some of you might remember 45s this way because 4 and 180 reduced to be 45. That's kind of more the mental math way of thinking about it. But yeah, we have our 45 degrees being 1 pi over 4. But 1/4 and 1/4 makes a half. We already have him. 3/4, well, that would be over here somewhere, right? So we'd have 3/4 of our calzone, or 3 pi over 4. 4/4 would be right here at pi. Another fourth would be 5/4, yeah? 6/4, well, that'd be 1 1/2. We already have that. 7/4. But here's something with all those 45s. All those 45s go back to geometry and help you or have you review this thing called special triangles. Where a 45-45 would have related to a 1-1 root 2 triangle. Oh, geometry. Except this triangle actually would be way too big for my circle because my circle says, no, the radius is only 1, not root 2. Root 2 is bigger than 1, so actually we'd have to scale these all back and say, no, you're too big. Now this is better, haha, 1. Except, ew, those aren't rationalized. They would be, ooh, anybody remember the special ratio root 2 over 2? So all of my x's and all of my y's for pi over 4s are all going to be root 2 over 2s, except, well, we have to be careful of our signs. Like in the first quadrant, they're both positive. But in the second quadrant, wouldn't I go a left with my x and then up? So wouldn't I have negative root 2 over 2 and positive root 2 over 2 for the y? Down here, I would have negative x, negative y. In the fourth quadrant, I would have a positive x and a negative y. Kind of going back to chapter 1 when we were talking about each of the different quadrants and whether we have positives or negatives. We're kind of 2/3 the way through our circle, but in other ways we're kind of just 1/2 the way through our circle, because maybe if you guys have been tracking, we don't just have 0s and 90s, we don't just have 45s, don't we also have 30s and 60s? Now 30s and 60s are a bit trickier. Not impossible, a little bit trickier. Because it says I need to take this 90, and last time we took the 90 and we split them in half, and that was easy to make the 45s, but this time doesn't split the 90 in half. Do you guys see what 30s and 60s split the 90 into? Isn't it thirds? Right? Ooh, okay, to get those lines is a little bit harder. These you guys think kind of like a burrito. Burritos, don't you like fold one side and then fold the other one on top of it? We gotta do the burrito with the 90. Ready? Because we're gonna take this side and we're gonna have him go not to the 45, but a little bit past. And get all my toppings in, including that 45. See how I went a little bit past? You go to my 45, a little bit past. So I have to get this line a little bit past. And if I did it right, you might wait to squish it. It should come back over and meet on the other side. If you want to get it as close as possible, you want this line to be in the middle as much as possible. Take a burrito. I have to wrap it over the toppings. Go a little bit past the 45. Come back. If you guys have ever eaten those bugle chips, it's a lot like the bugle chips. Or like a sugar cone that's been like wrapped around.
Oh, yeah.
Boop.
I did it.
If you got them, you should have just split your 90 into thirds. 1, 2, 3. And if you unfold, now you got all your 30s and 60s. The unit circle isn't meant to be magical or crazy or weird or just this random thing you memorize. It really is just fractional pieces of pi. To give it like a reference system to be able to play with sines and cosines and tangents without just or only being able to use our calculator. There are special triangles in geometry. And the unit circle deals with those special angles. So wait a minute, if we cut 90 or a half a calzone into thirds, didn't we cut the whole thing? The whole calzone, which is half a circle, into 6, right? We got this guy into 6, so we have pi over 6 being here. 2 pi over 6s is pi over 3, or 1/3 of that calzone. Wait, and we talked about on Thursday how if you go up pi over 6, you can also take 6, 6, like all 6 slices, and then go 5, 6. Or 7, 6. Or 11, 6. I know, I'm talking. You guys see how we almost have the whole thing filled in? We're going to finish filling it in right after we grade 4.1 tomorrow. And then we're gonna say, great, now what? What do we need to do with all these things? Alright, cool kids. Keep the pad paper in, and you're gonna be able to glue it, tape it, staple it, whatever you want to your notes tomorrow. And you can use it as a reference for the rest of the chapter. Bye guys. You guys need me 3 to 7 after school. If you need to come check in.